Please welcome to the stage Venko and Peter talking about backup and disaster recovery with CloudStack and StorPool. Thank you.
So this is actually, it was supposed to be a workshop, but it would be more like a demo. And we don't have much time, and I'll let Peter first to explain how what we'll show they operate for almost 2 years.
Yep.
And why this is important, and yeah.
Yep.
And then we'll do the actual demo. We'll explain in detail. I will explain in detail how actually this works, and hopefully the demo will show how it happens.
Thanks. Yeah, so my name is Peter Grayson. I work for Quadris. I'm the commercial
Sorry, use the mic, please, guys.
Sorry, Peter Grayson. I'm the commercial director for Quadris. Quadris, managed service provider based in the UK. We've been providing public cloud services for about 18 months now, maybe touching on 2 years. Traditionally, we've been providing VMware clusters for customers either on-premise or in co-located data centers with really comprehensive DR protection. So usually stretched clusters, active failover. Now we were looking to move some of those customers onto a cloud platform that we hosted, infrastructure as a service, more of a defensive mechanism really to stop them to move into Azure and us losing control and revenue from them. So it was really important for us when we were choosing a cloud platform and a storage provider that we were able to get DR protection from it. And when we started looking in the market, we were amazed that we really struggled to find a cloud platform provider that was able to do that, and a storage provider that had even considered DR protection to this level. So we started to talk to ShapeBlue, Alex and Lucian to talk about the art of what was possible. And we decided to start looking at stretch zones. And then we started to speak to StorPool about what was possible. And Venko and the team were brilliant. They worked really collaboratively with us to design this DR solution that Venko is about to show you now. And we've been, as Venko said, we've been using this in anger for about 18 months now. We've got several successful DR tests of this system, and we test it regularly in our DR environment as well, and it works. It does work really well. Okay.
Thanks. So we'll start with how this is built, how it operates, and to explain different components and what's its role, and then we'll continue with the demo. At a very basic, there are 2 data centers. So this specific demo will be, the data center will be active data center and DR data center, but exactly the same principles and technology can be used for active, where each data center backups the other one. And in each data center we have KVM hypervisors, CloudStack management server, primary storage and secondary storage, and one network that is stretched across both data centers, so you have the same network services across both data centers. And when you move some workload from one data center to another, you can use the same network services and the same setup. You don't need to reconfigure the applications. So I will not go here in details how the network is implemented, and I'll also not cover here how high availability of control server, CloudStack management server is implemented. So this is a standard practice with CloudStack. I have a HA on the CloudStack management. I'll cover here mainly the storage and how to move the workload if the main center goes down without losing data. So to do this, we need first to have to replicate the data that is in the primary storage to the DR side, and also typically would need a replication of the secondary storage. But in our case, we can skip this. So the important part is to be able to preserve all the configuration of CloudStack management when it's switched to the other side. So this is covered with the standard HA technique and database replication. And the network, of course, replicates the configuration on both sides. So before going into technical implementation, let's first see how this DR setup can be configured and present in CloudStack. So the trivial approach would be to have in CloudStack 2 different zones, one for the main side, one for the DR side, and each zone to have a cluster with hypervisor, a separate primary storage system, secondary storage system, and so on. Unfortunately, the problem with this approach is that until the latest and the newest version 4.19 that's still not available GA, there is no way to move resources from one zone to another. This means that if you need to move a virtual machine from zone A to zone B, you need to create another instance with the same settings and hope that all other resources that you use will have a corresponding mirror at side B. Actually, Alex, I think from Shade Blue tomorrow he has a presentation on this approach. But we will see here how this works with a current CloudStack and some few interesting features. So we will not be able to use multi-zones for this because of this limitation. So to do DR, the solution was, and what still we use in present, is to have one zone that is stretched across both data centers. So both data centers can be remote data centers, for example, a few hundred kilometers from each other. We don't need to keep the latency at the minimum. And each data center is presented as a separate pod. So we have a stretch network covering both pods, so both data centers. And in each data center, we have a separate primary storage. But one important note here, we use a StorPool specific feature to combine multiple storage clusters into one multi-cluster configuration that is presented to CloudStack as a single zone-wide primary storage. And we have only one secondary storage. So in order to use this approach, there are few features that are StorPool dependent. So first is to be able to asynchronously replicate volumes or snapshot, in this case, snapshot between the primary storage clusters. So in this case, volumes that are here, we need to have snapshots and to send these snapshots to the secondary, to the DR side. The other required feature is bypass secondary storage. So bypass secondary storage, it is supported by StorPool and I think a couple of other primary storage systems in CloudStack. When you create a snapshot, when this feature is enabled, snapshot is not sent to the secondary storage, but is kept only on the primary storage. So the secondary storage does not keep any snapshots. This way, when we switch to the DR side, we have all the snapshots that were created because they are in StorPool and they are replicated to the other side. And we do not depend on the secondary storage for this feature. And the next one is multi-cluster configuration. I already mentioned it. This is to be able to combine both storage clusters as a single primary storage that is zone-wide. We'll see why this is important at the end. But for CloudStack, this is one single storage system with a single continuous namespace, one API endpoint to control. So it's basically one system for CloudStack. And the last one is to have regular snapshots created on the primary side and sent to the DR side for backup. So if the main side goes down, we will have a snapshot made recently. So let me see if I missed something. Yeah, I missed something. This is that templates that are stored on secondary storage are also cached on the primary storage on their first use. So with this feature, we do not depend on the secondary storage because the snapshots are on the primary storage, the templates are already on the primary storage. So if the secondary storage goes down, nothing wrong will happen. Still, this solution requires to have a secondary storage, but it's not as critical as with usual deployments. So that is at a very high level what we do, and I'll explain exactly the steps during the demo. And for the demo setup, this is in our lab in Sofia. We have 2 pods with 2 KVM hypervisors. The first one represents the main side, the second one is the DR side. 2 StorPool clusters in a multi-cluster configuration with asynchronous replication of snapshots every 5 minutes. Snapshot of all the disks and virtual disks are created and are sent to the secondary storage. We have to the DR side. Sorry, we have a secondary storage that is NFS in the CloudStack management server. So we will not cover here the management server and the CloudStack failover. And so this is the CloudStack. So we have a single zone with 2 pods, port A and port B. Port B at the moment is disabled. The reason for this in normal operation to have port B disabled is to have all virtual machines started on the main cluster, and also more important, to make sure CloudStack runs all the virtual routers in the local data center, so the data would not travel through the far distance link and introduce latency. If you have active deployment, then you have to take care so the virtual router are at the same pod where the workload is. So we have 2 hosts and 2 VMs currently running on KVM1. Okay, so in normal operation, we have pod B disabled, already explained why. We have all user VMs, system VMs, virtual routers, everything is running on main data center. In this case, this is KVM1. We have enabled bypass secondary storage. Templates are cached on the primary storage. And volume care, this is a StorPool feature or scheduler that creates regular snapshots of every volume and send these snapshots to the remote cluster and maintain the retention policy. In this case, for the demo, it keeps only 1 local copy of the snapshot and 1 remote copy of the snapshot. So this is sufficient to have the DR functionality. You can have a larger retention policy if you want to have a remote backup functionality, so you can use the DR site also as a remote backup location. And let's get back here. CloudStack management server is using the endpoint of StorPool 1 cluster. So with this multi-cluster configuration, through 1 endpoint, you can control both clusters because they are present as a single cluster. Okay, so when the main side goes down, so let's do this with a demo. So I have here, this is the main StorPool cluster. Sorry, but okay. Here are the volumes in the main cluster, and this is the main KVM1. All the virtual machines are running here, and here is the CloudStack controller. I have prepared a number of scripts here to execute these failover tasks. So let's get back to this and first actually make the disaster. So we will stop KVM1 and StorPool1 at the same time with directly power off the server without graceful shutdown. So so this is what we will do. We will directly stop the power using APMI. And okay, we'll stop it. Okay, both servers are down now. So we need to proceed with a failover procedure. We identified that we need to switch everything to side B. So first is to fence all hypervisors on the first side. So it's important to make sure that no virtual machines are running. In this case, we know hypervisors are down, so there's no chance virtual machine is running there. If we have virtual machines, there a lot of nasty things can happen, so this is a very important step. Next is to switch CloudStack to use the second StorPool API, because it loses the connectivity to the StorPool. And to do this, so you can do this with an API call. I'll do this using the web interface. So we need to change just one parameter here. Let's hope because I cannot see it well. True. Is it? Yes. Okay, thank you. So this will tell CloudStack to use alternative API already defined. So I don't need to configure it. Then we need to tell CloudStack that all virtual machines that were on site A are actually not running. So we'll be able later on to start them. So we can do this using web interface, or we can. Okay, let's stop there. Power off, not destroy. Okay. And force is very important. Okay, and it may take a minute. So number 4, delete template reference. As I said, templates are cached on the primary storage, but for this specific deployment, we do not transfer this cached snapshot or templates to the other side. So we need to tell CloudStack that there are no any templates cached on the primary storage, and you need to download it again from the secondary storage. And this is delete template reference. So unfortunately, this is a very ugly hack. This directly deletes from the CloudStack database the references. In the next version of the StorPool plugin, we will not need to do this. It will handle this automatically, but with the current version, you have to do this. And now we need to enable DR site and disable Porte A. So all the system VMs and virtual routers will be started on the DR site. And let's get back here. So enable this one. Disable this one. Okay, and we need to destroy system VMs that are still CloudStack still thinks they are running on site A. I'll use a script that basically executes these commands. So list system VMs. Okay, it still thinks that they're running on Porte A, and I will not this one. delete system VMs. So, so this is execute asynchronously, and we need to do the same for the virtual router. Let's give it a few seconds. Okay, I can do this using the web interface. Virtual router. Go there. And delete it. Okay, so with the disaster part, we are ready. Everything seems okay. So let's see if we'll be able to recover the virtual machines. So, yeah. So to recover the virtual machines, we have all the preparation, and now we select the virtual machines that we would like to recover, or the order we would like to recover the virtual machines. So for each virtual machine, we need to get the volumes that are used by this by the specific virtual machine, to find the latest snapshot that we have on the DR side, to create a volume from the latest snapshot that we found, and to update ACS that the virtual disk is now using this new volume that is currently on side B, and start the virtual machine. So I'll use this script that executes all these tasks in order, and for all virtual machines in parallel. I'll put some debugging and tell that it will need to be asynchronous, and will provide the ID of the virtual machines to be started. Okay, and let me try to increase the font maybe. So I'll skip the non-important stuff. So we have found for this virtual machine a backup, and the latest backup was created 12 minutes ago. And we use this snapshot to create a new volume. So this is the volume ID, and then update the CloudStack that it will use this volume for this StorPool volume for the CloudStack volume. And the same for the other virtual machine. The other virtual machine has two disks. It has one root disk and one data disk. So we need to do this twice for both. And if everything was successful, let's see what would be what is the current result. So let's get back here, and they are still stopped. Okay, so something didn't happen right. Well, unfortunately, these applause are not for me. So.
If you start them, Venko, they would already be stopped if you didn't manually start them, unless they've got HA in it.
The script should start them. Let's try to start them. No, it's. I guess the router is not running. Where is this?
They're not the X. They're right and X. Right.
Okay, thank you. Yep, it's something with this router, and if it's, let's try to delete it again. Because of the old router is not deleted, it didn't start the new one, and that's why it cannot start the virtual machines. Well, I should use the script. No, it's, sorry? Yeah.
That is what we do. Get rid of the database.
Well, I'm afraid I will not have a time to do this, but can you help me which table? Sorry? In VM instance?
Underline instance. VM.
Ah.
Wow.
500 instance.
Click on the
Какво търсим? Name? Няма става така, нищо. Where is this? R5 set. Okay, so ама прекъсваш ми кабела. На какво трябва да стане? Само първата или всичките? Така? Okay, very ugly hack. So hopefully.
You need to set the remove it to now. Remove it to now. Remove it
Yep.
to now.
Delete it or?
Set remove it, remove table to now. Now is a full.
Yeah, yeah. Thanks. Okay, so this starts to look like a workshop. Yeah, okay. And now, yep. If we try to start the virtual machines, I guess it will start. She checked. Start instance. Okay, I know. Let's see if we have a system VMs if they're running. Okay, we have one system VM is running and another one. Okay. Let's give it some time. Okay, one of the Virtual machine is already running. So I guess the other one will need a few more seconds. Okay, let's see if we have access to this virtual machine. So this was the old one before we lost the hypervisor, and yeah, it's running. Thank you. So, and it's running on KVM2. The other one is it? Okay, it's still starting. I'm not sure what's wrong, but okay, we have half success. So basically, this was the main part, and I have prepared, if everything were okay, I have prepared another task, Failback, how to move to the main site when main site is recovered. I'm afraid we don't have much time, so to demonstrate this, the procedure is really simple. When the main site is recovered, we need to delete all stalled volumes and snapshots because all the newer versions are already on in the DR side, and we don't need anything from the outside. Then enable Porte so it can handle virtual machines and just do live migration, since we have a shared zone-wide primary storage. Live migration works between the pods. So the failover is pretty straightforward. Yeah, and basically that is my demo. Half successful, half not.
Thank you very much, Venko. Any questions in the room for Venko or Peter? Alex.
You mentioned the snapshots are copied every 5 minutes, right?
Yeah.
So that's your RPO?
For the demo. For production deployment, it would be larger because of the way asynchronous replication in StorPool works. So it creates, so you can create snapshots at whatever interval you'd like, and then transfer the snapshots to the remote site. And depending on how many volumes you have, and so how many snapshots you create, and the bandwidth of the link between the sites, you have to make a trade-off between the number of volumes and the frequency of the snapshot. Important thing here is that over the link are transferred only the changes, so not the full volume images. Usually an hourly snapshot is about 0.2% of the volume on average of the size of the volume. So if you have, let's say, a 100 gigabyte volume, you can expect about 0.2 gigabytes snapshot to be transferred. So you need to tune your system, and it depends on how many changes, how many writes you have in this volume, of course.
Okay, thank you. So to point out that both VMs are now running, by the way. We've got one question from the online audience. Do you plan to add the option to remove volume snapshots from the primary storage after copying them to the secondary storage in order to optimize storage space usage?
Yeah, so at the moment we keep one copy on the, removed from the primary and to move it to the secondary storage, right? This was the question, not to the DR side.
Remove volume snapshots from the primary after copying them to secondary.
Okay, no, at the moment we don't plan to do this. So there is no significant benefit of doing this. And the reason is that if we need to keep the snapshot on the secondary storage, each snapshot should be stored as a full image. While in StorPool, snapshots are stored only as the changes. So, for example, if you have, let's say, 10 snapshots, each is about less than %, you have 10% increase in the usage of the primary storage versus saving of 10 times the volume size on the secondary storage, and there is no real reason for this. Also, restore from snapshot is much faster this way compared to downloading from the secondary storage, so there is no good advantage.
Thank you, Venko. Any more questions from the room? Okay, before we thank Venko and Peter, sponsored drinks are in the conservatory, which is on one floor up. Lift or stairs are out towards the restaurant. Hope to see you all there for a drink. Please join me in thanking Peter and Venko for today's last speech.